Lesson 3, Equivalent Circuit. Section 3.3. Input Circuit. In Section 2.3, this input characteristic was obtained. The approximate curve was found to be expressed with Fermi-Dirac probability function. And we saw these changes, delta VBE and delta IB. The curve within the range of changes has a nonlinearity. The aim of this chapter is to identify a linear equivalent circuit of a transistor. To achieve this, we need a linear approximation of its nonlinear curve. For that approximation, we have to determine the operating point of the transistor circuit. In experiment 2.2, VBB was set so that V bar CE equaled 3 volts. By this setting, V bar BE became 0.66 volts. Let's select this value for the operating point of this circuit. In this graph, if VBEQ equals 0.66 volts, then IBQ equals 2.85 microamps. Q denotes the operating point. The linear approximation of IB versus VBE curve employs the tangent line at the operating point Q. The tangent at Q is the differential coefficient dIB dVBE at VBEQ. And it is derived as this equation. Its inverse is defined as the input resistance HIE, where VT is called thermal voltage. This is the input circuit of equivalent circuit. It has the input resistance HIE. Note that Vs, VBE, IB contain only AC components. The equivalent circuit models only AC components. Exercise 3.3. This is your homework. Pause the video, and answer the problem. The author of this material is Takeshi Furuhashi, Professor Emeritus, Nagoya University. If you have any questions, send emails to this address.